Before starting ZTech AI, Jansok was a senior software engineer at Qualcomm AI Research, where he led the development of low-power AI platforms for embedded devices. His expertise lies in optimizing AI models for real-time deployment on specialized processors, making AI accessible and efficient on everyday hardware. Jansok's innovative work has been showcased at events like CES and Neural PS. Today, he'll be talking about how we can transform everyday smartphones into AI powerhouses, making advanced AI accessible without new hardware. Okay, please welcome Jansok.
Thank you for the introduction, and nice to meet you, everyone. My name is Jansok, and I'm the CEO and co-founder of the ZTech AI. So before starting the slide, I'll briefly introduce myself again. When the AlphaGo came out to the world, I joined the Qualcomm AI Research Lab for as my first career. So I started on-device AI when the on-device AI world is not existed. So I started my career with embedded AI itself. So at 2018, I presented embedded AI at the CES about utilizing the audio speech AI models with utilizing the AI things in the Qualcomm's NPU devices. So those kind of AI models our team has reproduced was deployed to the Amazon Alexa home speakers and Samsung Galaxy's underscreen fingerprint sensor and Microsoft Cortana AI assistant and those kind of Baidu, Xiaomi or global smartphone companies. And after that, I was keep developing the on-device AI software framework using the Qualcomm's NPU. So and until 2021, I released the on-device AI software framework to the commercialization team, and the software framework was developed by 2 software engineers, and now we deliver to the 30 or 40 more Canadian teams utilizing them. And after that, I was keep researching in the on-device AI domain, and I represent the demo for the on-device AI on-device training at the NeurIPS, which is the most famous AI conference in the world. And then after that, I founded the company ZTech AI to utilize the on-device AI hardware not only for the Qualcomm but for all different devices in the world. So I guess everyone already know that AI companies is struggling to make profits with AI services, but it's very hard to make money because of the GPU cloud cost. So all of the AI services are utilizing the GPU cloud for their AI computing process, but the GPU itself is very expensive, not only to establish, but also to maintain. So basically, the OpenAI had 15 billion loss for their AI services, and this kind of problem occurs the needs for the revolutionize of the AI structure. From this background, on-device AI has grown up with the attentions that the biggest advantage of the on-device AI is that it replaced the GPU cloud computing to the user's devices, so it can reduce the enormous cost of the company side. And plus that, from that, the on-device AI doesn't need the network connection for the GPU cloud server. There are other advantages came out about the energy efficiency, and it enhanced the user's data security as well, and it offers the offline functionality of the AI processes. And it doesn't have network latency, so we can enable the real-time process for the AI computing. So it increased the reliability of the AI to everyone. So to maintain or to build the on-device AI, there are 3 key elements are needed. So the first one is the computing power to replace the GPU cloud AI computing to runnable in the edge devices. And the second one is making the smaller AI model to deploy the heavy model to the smaller for target to runnable with the target devices. And third one is AI software framework. They're running the small AI model in the computing powerful target device. So let's see one by one. So let's think about the target device first. So Apple and Qualcomm have relatively released the MPU, which is AI specified target processor from 2017 and 2018. So from Galaxy S10 and iPhone 8, MPU had released and spread out to the world. And the MPU is faster than traditional CPU and GPU, up to 60 times faster, and it consumes enormous less power than CPU and GPU in mobile environment. So now, 2024, MPU has spread out to the world from 2017. I guess in this year, everyone has MPU in your palm, in your pocket, and everywhere. So for making the smaller AI model, there are three representative methods to make smaller size of model. First one is pruning. It's literally pruning like a tree. So pruning is removing an important part of the neural network to make the model smaller. But actually, in the on-device AI side, we do pruning for the layer-wise. We don't pruning the parameter-wise because for the accelerating the matrix multiplication, it is faster. It doesn't make faster to like sparsity of the parameters things. So we have to do the layer-wise pruning. And second one is quantization. Quantization itself is actually the very like traditional technology to make small size thing in the computer science. So basically, the base type of the AI models are consistent with floating point 32-bit floating point type, and if we can represent those data to the low bit precision, we can make the AI model smaller, right? So traditionally, the model optimization companies are focusing on making those kind of parameters to the integer 8-bit parameters, but it increased huge error rate of the representing those type of floating point to the integer point. So recently, there are like bunch of like researches to represent the 32-bit floating point to the 60-bit floating point and 8-bit floating point. And third one is knowledge distillation, and it is very simple one that it is consist with the teacher model and like student model. So it transferred the knowledge from the larger model to the smaller model. It's a very like simple structure, but it needs the additional training for the making the smaller size of model. And third one, let's see about the AI software framework. So as you might know, the TensorFlow PyTorch is a very well-known software framework utilizing the NVIDIA GPU and in the training side. So they are a very general AI framework used to build, but for the perspective for the on-device AI, they are already too heavy to be run in edge devices. They are targeting to train or run the batch process at once, but actually in the on-device AI, there is no need for the batch process. So the key is that they are too heavy to run to be in on-device. And second one, there are approaches like GGML, which is like AI framework consisting with basic C++, and it is available to utilize other C++ library. But the limitation of the GGML is actually there is a mistype that it cannot utilize the mobile MPU SDK because they are not opened in C++ library. They are opened in the SDK, not in the library side. So plus that, to utilize the heavy model in the on-device AI, it split the all weight to be loaded to the small side part of the network, neural network. So it caused too many memory pieces produced inefficiency in edge environment. And so to utilize the MPU, the hardware companies are producing their own SDK. So Qualcomm is making the Qualcomm AI SDK, and Apple is making the Core ML, which is using the Apple's MPU processor, and MediaTek is making the NeuroPilot, which is their own SDK. So the key is that every other hardware company is making their own SDK. So if you'd like to make a general AI application for the on-device environment, you have to support everything. So there are no generalized frameworks. So to release the global MPU using application, you have to support all different type of SDK. So here's the thing. I said 3 key elements are needed for the on-device AI. So the computing power for the target devices. So MPU is inevitable for utilize the AI processing in like mobile environment, because I think you might already know that people normally don't wait long in their palm. They normally refresh for their like browser. They don't wait a long time for here. So we have to use the MPU to perform the best performance in the mobile environment. So to utilize the MPU, we have to build the system to support each other manufacturer's MPU SDK. So with studying and building those kind of documents from those kind of documents for the hardware utilization, it has to be ported to the mobile operating system as well. So it takes about at least a year to build the on-device AI. So there are other approaches from the PyTorch and TensorFlow. So PyTorch started to develop the executorch, and TensorFlow started to develop the LiteRT from the a little bit transformed from the TensorFlow Lite. So they are focusing to utilize the MPU, but they couldn't remove the legacy framework, so they heavily rely on their original framework. So there is still limitation of the heavy framework itself. Plus that, to utilize them, you guys had to make setup from beginning of the platform build. So it takes a long time as well. So our company is focusing to make those kind of pipeline to make faster. So the approach that we have is that we are providing the easy and fast utilization for the MPU, and we are providing the heterogeneous MPU support to utilize the mobile on-device AI. And third one, I said that integer type quantization increase the huge error rate, so we are providing the lossless optimization. So here's the thing. So from the 1 year pipeline, we automated the whole pipeline in one pipeline, and from that, from AI model, we enable the on-device AI transformation in a day. Plus that it needs only 2 steps from model. From the model, we can generate the library code, and then we can get the user model key, and from the user model key, there are only two source codes are needed for both for Android and iOS. Plus that, for utilizing the heterogeneous MPU, currently we support the mobile operating system, Android and iOS, and plus the mobile Linux. So we support the 99% of the mobile operating system, and presently we are supporting the Qualcomm and Apple and MediaTek's MPU, and we are keep expanding to the Uniso and other MPUs as well. So we support the 80% of the global mobile MPU, and it's going to be the 89% from we support the Uniso as well in near future. So for the model optimization, we support the 16-bit floating point model optimization. So if we convert the model into integer side, the error rate goes really high. It goes around at least 2 times. So from converting the model to the 32-bit to 16-bit, it doesn't really cost a lot to retraining or those kind of things. Plus that, it doesn't increase the error rate of the model. So here's the pipeline that we built. So from the AI model, if we get the AI model to deploy to the on-device thing, we run the global device benchmark, and we run the actual devices and get the latency from the whole models with utilizing the MPU. And we compare the result of the different types of like models, compare the models, and we we are setting the model to be perform the best performance. And if we deploy the library with the users in the market, from the user side, we detect the user's device and we get the best performance model from our model pod. That's how it goes. So please imagine what on-device AI can get in near future. So there are 3 key benefits with on-device AI. For the users, the first one is the network independency. So in underground, in subway, in even the underwater, even in the spacecraft, we don't need the network connection for the AI inference. So we can do the AI service. We can get the AI services in everywhere. The second one about the real-time performance, from the reason that we don't need the network at all. So there is no network latency at all. So if we have to those kind of healthcare monitoring or some kind of image processing or like sound classification or even for the noise cancellation, we have to send the whole data to the AI cloud server. But with the on-device AI, it is not needed. So we can do the real-time performance for the healthcare monitoring systems and anything like AR and VR. Third one is data security and personalization. So if we have AI assistants near us, we have to send the whole data of our privacy to the GPU cloud server in the company side. But it's ridiculous. So everyone doesn't really care about the data privacy even when they are using AI. But actually, their personal information goes to the company side. So to protect the user's data, it is very clear that we can remove those kind of dangerous situations by not sending the data to the company side. So on-device AI increases the user's data security and it offers the personalizations for the AI services of yours. All right, thanks for listening, and yeah, thanks for your time, and please ask me anything.